Hello and welcome back to Unit 2 of our math review for our SOL standards for 7th grade in Virginia. And reminder that this Unit 2, decimals and scientific notation, is a non-calculator portion. So this paper here is what I went over in the first video in this Unit 2 section. And if you want to go back and watch that for a quick little review and a rundown of what Unit 2 is all about, please go back and watch that first video. Second video, I just went over what the difference is between a positive and a negative exponent. And so I went over it with some powers of 10s, and then I also went over it real quick with just 2 as my base. And the process is the same no matter what your numbers are, the difference between a positive and a negative exponent. So now for this third video, I'm going over what must you consider when comparing numbers written in scientific notation. And that is not a super duper simple question. I'm definitely going to go over a few examples here, and hopefully it'll help us out. So, briefly go over what we went over. There's a lot of overs. In the first video, I made a little diagram and a little reminder of how scientific notation is written. And so this is asking us about comparing numbers written in scientific notation. So in case you have not watched the first video in Unit 2, or you just skipped up to this one, here's just a quick little reminder that we have what's called the coefficient. That's the number in front of the multiplication sign. And then we have our base, which is always 10. And then we have an exponent. And a positive exponent means we're getting a bigger number, and the negative exponent means we're going to have a smaller number. And if you watched the last video, you know that's because it's being divided repeatedly. Also, a quick reminder that this first number, the little 4 right here, or if it was a 1, 2, 3, 4, any number that's in front of the decimal for this has to be bigger than 0. Has to be bigger than 0. So A is bigger than 0, or it also has to be less than 10. So just a quick reminder, I cannot have 10 in front of my decimal here for scientific notation. That would mean that I made it incorrectly. So this whole thing has to be bigger than 0, less than 10. My base is always 10. My base is always 10. And my exponent, if it's positive, it's going to be a bigger number, which also means my decimal moves to the right. And if it's negative, I'm going to have a smaller number, also known as my decimal moving to the left. Okay, and then a quick little reminder that our standard tells us and reminds us that we may see questions asking us to order scientific notation in 2 different ways. One of them is ascending, one of them is descending. So don't forget the difference between these. Ascending is least to greatest. Least to greatest. And I'm going to draw a little arrow up. If you get in the elevator and you're going up in the elevator, then generally you're going to start at the first floor, go up to the second floor, third, fourth, fifth. So you're going to start at the smallest floor number, and you're going to be going up. If you're going down in the elevator, then you might start at the 100th floor, and then you're going to be going down all the way to floor 1. So greatest to least. And I'm going to draw a little down arrow. So ascending versus descending, 2 different ways that we might need to order our scientific notation numbers. So let's just jump right into an example that you might see on an SOL, on a worksheet, who knows. So if I have, and again, our standard did let us know that we're going to have nothing more than 4 numbers to compare. So 3.42 times 10 to the 6th power, okay? And then 6.31 times 10 to the 12th power. Let's do 4.89 times 10 to the 23rd power. And then let's do 1.2578 times 10. Let's do also to the 23rd power. Okay. So the first thing we're going to do is we're going to look at the exponents. Look at the exponents. And again, that's 6, 12, 23, and 23. So that's where we're looking first. So a bigger exponent, as I said here, a bigger exponent implies a bigger number. And what's called the converse is also true. So a smaller exponent means a smaller number. So a bigger exponent means a bigger number. So if we're looking at the exponents, then 6 is smaller than 12, which is smaller than 23, but that's the same as 23. So first thing I'm doing is looking at the exponents, and I know that 6 is going to be the smallest number. Regardless of what it says here in the front, that is going to be my smallest number, 3.42 times 10 to the 6th. All right, so then looking at these that match 23 and 23 as my exponents, what do? So if the exponents are equal, what do? Let's look at the coefficient. Look at the coefficient. So if I'm comparing 4.89 times 10 to the 23rd and 1.2578 times 10 to the 23rd, okay, which one is bigger? Something that starts with 4 or something that starts with 1. So, let's see. 4 and 1. Which one's bigger? Hopefully everybody is saying 4. And that is correct. So 4 is bigger. So this is my bigger number. So if I wanted to order these from least to greatest, this would be the least, number 1. This would be the next least. And then this one was smaller. And then this is the biggest one. Okay. So we got 1, 2, 3, 4. Okay. Now, let's mix things up just a little bit. So let's take those same numbers we just looked at. 3.42 times 10 to the 6th. 6.31 times 10 to the 12th. 4.89 times 10 to the 23rd. And 1. I messed up. We can change that number a little bit. 5278 instead of 2578. And it's still going to be times 10 to the 23rd. Now, that's not super duper helpful, Mr. Cheney, because that is the exact numbers we just looked at. But what if they were all negative? What if they're all negative? How does that change things? If I still want to go in ascending order, let's put them in ascending order. So remember, that's least to greatest. All right, well, which one of these is going to be the smallest number now? Last time, I do believe, it was 3.42 times 10 to the negative 6, because 6, I hope everybody agrees, is smaller than 23. But remember, negative 6 is actually greater than negative 12, because negatives work backwards, or count backwards, however you want to say. All right, remember that if I had a number line, we have negative 12, negative 11, negative 10, negative 9, 0, 9, 10, 11, 12. So even though our normal positive numbers go 9, 10, 11, 12, 12 being the biggest, actually, negative 12 is the smallest of all of those. So if there was on a number line, which has arrows on both sides because it goes infinitely in both directions. All right. Negative numbers are opposite. So actually, -6 is going to be the biggest one this time. So that's going to be my 4. This is going to be my 3. And then here's where I have a little trick I got to do. Okay. I have -23rd power and I have -23rd power again. So what do? Okay. Well, thankfully, there's no trick to it really. 6.31. Oh, wrong number. That's my other example. 4.89 is still bigger than 1.5278. So it's actually going to be 4, 3, 2, and this one is my smallest one. Okay, so that's just a quick little thing. So the first thing you're going to look at is the exponent, order them from least to greatest or greatest to least just based off that. And then if you have numbers that are exactly the same, you can sort them based off of the coefficient, whatever is least to greatest based off of that. And they don't matter whether the exponent is negative or not. That was a bit of a longer video, but I hope it helped.